Hiya, thank you everyone for joining. Hopefully it'll be a very informative webinar for you. And yeah, thanks for joining from wherever you are in the world right now, because I think we've got quite a diversity of people on board. My name is Alan Pantning. I'm with my role in Not So Secure Global Services is effectively just to help customers across Europe, Middle East and Asia have a good working experience with us. I'm part of a global team to deliver what we consider a world-class ethical hacking and training service. Shortly, I'll be handing over to Scott, who's one of our security consultants, but also one of our black hat trainers. But if you don't mind, just before we get kicked off, I just want to tell you a little bit about us. Pretty much everything we do is around two headings. As you can see on the screen, we hack, we teach. When I say under that heading, there's lots of things under that banner. You know, we've got web infrastructure, mobile, source code, there's a whole raft of things. Plus on the training side, we've got from very basic through to very comprehensive hacker type training. We also do some other clever stuff like MDR, continuous security testing, and general security consultancy. Overall, about, I don't know, 20 odd years experience. So we like to think we know what we're doing by now. One of the things we're proud to call ourselves is one of the largest hackers training organisation for the famous, well, say security famous, so Black Hat, which run every August, normally in Las Vegas. We normally train around 500 people at that event. So, you know, quite a big event to us. We also train with a few other security training partners like QA and Checkpoint. A lot of people have probably heard of those, especially in the UK. So cloud storage security, yeah, interesting subject really. I mean, cloud training itself is probably one of our most popular training courses we run, especially at Black Hat and other major events. Pretty much every organization has some sort of cloud usage nowadays, whether it be a mixture of in-house or public cloud or fully cloud-based. So don't get me wrong, cloud is a good thing, very sensible move, but adapting new technologies obviously carries new risks as well. So hopefully we'll get that put over to you in this webinar. Just to point out though, this webinar is an introduction. Bear in mind, it's extracted from a training course that can take 2 or 3 days. So condense some of that into an hour is challenging for the instructor to start with, but it's also just to give you a good flavour of what it's all about. Right, so just as you see on the screen previously, we will be having a questionnaire at the end, and so that'll be an opportunity for you to actually get some free training if you want, and there's also some discount codes you can use, but you will get copies of this webinar, so you don't have to write them down right now. So hand you over to the man in charge. Scott, over to you.
Cheers, thank you very much, Alan. So yeah, as Alan said then, this webinar we're about to go through is just looking at one kind of service within cloud, blob or object storage. Cloud itself is a huge array of services, and with each of those new services comes new attack surfaces. We're going to have a look at object storage in this short webinar. Hopefully you'll find it informative, and we've got a couple of freebie tools that we're going to give away to help you assess your own exposure to some of the threats that we're going to look at in this webinar, and some guidance on what to do about them. So a little bit about myself before we get into it. My name's Scotty. I'm a senior security consultant with Not So Secure. I've got over 10 years of experience now, beginning with tactical and strategic intelligence collection. That sounds cool, doesn't it? But initially, my job was to undermine enemy communication systems and derive intelligence from them. So listen in to push-to-talk radios, or tackle the encryption that might sit on top of something like GSM and derive intelligence from that, or deny the ability of the enemy to use those communication systems to cause harm to UK or allied personnel. After my kind of tour of Afghan, doing all of that tactical stuff, I was headhunted for a strategic role to mentor 2 different cyber capabilities that were being stood up in Cyprus. So I did that for about 5 or 6 years out of Cyprus, built up these new capabilities, and because I'd spent so long in that mentoring role, it was a really natural transition to move into the private sector and begin cybersecurity training, which I did for QA, one of our training partners, for a while there, and I left as head of cyber product development to join Not So Secure and teach their courses exclusively. So what are we going to look at today then? Well, first of all, we need to understand what object storage is. We're going to see what differentiates it from other forms of storage like block storage. And we're going to have a look at its attack surface. And we're going to break down the two fundamental ways in which cloud storage gets compromised. Now, there are lots of individual vulnerabilities that can lead to cloud storage being exposed or discovered and compromised via another service through web application vulnerabilities, but we've broken all of that down into just two sections. So we're going to explore those and have a look at some live examples of cloud storage being compromised in different ways. We're then going to have a look at the evolving threats that cloud storage is subject to. Cloud storage is always going to play a part in whatever solution that we go for within cloud. If we properly architected our solution, it will be making use of object storage at some point. And so traditional threats like ransomware are now becoming cloud native. They're making use of those decoupled services within cloud to perform the same effects as ransomware on a local machine, except up in the cloud, and it is every bit as devastating as it is on premise. We're also going to have a look at Magecart, a fairly complicated attack when you get into the weeds of these various redirects that it caused people's browsers to do, but it all boils down to one simple exploit: misconfigured storage, which allowed a supply chain attack affecting tens of thousands of websites and users. We're also going to have a look at simple misconfiguration and how we can, or how an attacker could, abuse the misconfiguration of storage at scale. I've got a little tool that I've written for this webinar, which will look at just how easy it is to find documents that have been exposed in misconfigured buckets. And then finally, we've got some tips for defense. We've got some documentation that will help make sure that your storage is configured in line with the vendor baseline for security, and also some tools that you can run within your own subscription, and they'll tell you which storage accounts are configured in a less than ideal way. So what is object storage, first of all? Sounds self-explanatory, but there's a lot more than just putting an object in storage. The first thing is that we are completely agnostic of any kind of file system that might be applied. We don't need to know, how many disks or what size have been applied to our storage. We simply give the service an object. We give it any metadata that we want to attach to that object. For those that aren't familiar, metadata is data about the data. So if you uploaded a picture of a cat, you might have a piece of metadata called contents and then the words a picture of a cat. So a bit of a descriptor about what the data is. Then any attributes that we want to set and access control permissions, as well as a unique ID for that object. Now, the nice thing about object storage is that it's very easy to get up and running. It's almost infinitely scalable. You're never going to exhaust your cloud supplier, I would hope. And it's very quick to access objects. However, it's not as quick as block storage. So object storage doesn't lend itself particularly well to large applications that need to scale over time, like databases or massive SAP applications. For those, you would want block storage so that that server can find the exact record because it knows the physical location from its index of where that record is within a database. So it doesn't lend itself particularly well to structured data. That's where we'd rely on block storage. And the reason I've chosen to focus on this particular aspect of cloud services is that when we build our cloud services, we want to loosely couple them. We don't want to have a database server with its own file system and its own operating system and a web server within the same physical host. That would be a tightly coupled solution where all of your services are living in one host. It makes it quite difficult to migrate or scale or adjust that service over time as the changes become more and more difficult to track. In cloud, we want to break apart those individual things and consume them as services. So for Azure, they have their own hosted MS SQL service. They have their own storage service, their own web application service, And so really you'd want to use all three of those to provide the same function. No matter what you do, you will probably always use some kind of object storage. And so it's a fundamental component of almost any application that you're going to build. If it's left misconfigured, then your personal information and perhaps your information that you would use to generate money is going to get compromised and it then becomes worthless. So we're going to break it down into two main forms of attack, and the first is indirect attacks. So we are gaining access to the storage through another application in cloud that has legitimate access. So if you think about the example I gave before with a web application that has access to a storage account, well, we have granted a set of tokens to that web app that allow it to ask for access from the cloud vendor and be granted that access to the storage. So here we're leveraging the vulnerability in another application to gain access to that storage. From there, we gain access to records and anything else that's inside. The nice thing about this approach is that we're not generating new credentials and we're not compromising by brute force someone's credentials. We're simply lifting them from an application that has been granted that access. So we're going to have a look at a demonstration of this now. I'm going to talk you through this video as we go. And I may pause from time to time to add a bit of context. So first of all, I'm going to run this sts get caller identity command. I'm doing this from my own machine, and this command tells me who I'm logged in as in my cloud subscription. I'm logged in as the root user in my own subscription, but I want to break into this storage account, victim private. And as you can see at the moment, access is denied. We cannot gain access to that private storage because it's been locked down so that only named accounts can gain access to it. And this second command just demonstrates the exact same thing. Not only can I not list objects within that bucket, but I also can't read the access control list. I have zero access to this bucket. However, on further investigation, we realized that this service, this organization that we're targeting, hosts this web application. And by examining it, we can see that it relies on another Amazon service called Cognito to perform identity services. Now, Cognito allows you to grant access to your users to your cloud services. It's a great service. It's not inherently insecure at all. The problem here comes in the misallocation of permissions to unauthenticated users in the Cognito environment. But in order for us to get a set of tokens, we first need to see if we can sign up. Cognito allows users to sign up and register, provided they have access to these values, which we're now pasting into the AWS command line tool. And I'm just going to provide a set of registration information like a username and an email address. My video has decided to skip away slightly. There we go. So yeah, I'm just going to give it a username, email address for registration.
Hi Scott, sorry to interrupt, but we're just getting an AppSecOps screen at the moment. We're not getting what you're talking about.
That's strange. How about now? Is that any different? We see a terminal on the screen at this point.
I'm still only getting an AppSecOps screen at the moment.
Okay.
It might just be me. I think other people can see it. Ignore me. Carry on.
Okay. Have we got people coming back in the chat at all? If you can see, was it just you, was it, Alan? Oh, okay, no worries. Yeah, if anyone does have any problems seeing the video demonstration, or if it looks like it's frozen, just give us a shout in the chat and we'll get right on it immediately. So I've gone through this registration process. I've provided the client ID and an email address and password that I'm going to use. But well, first of all, I've got a bit of a typo in here. US East is not a valid region, so I'll quickly change that. But I can see that this Cognito implementation does not allow registration. So I can't get authenticated tokens. Instead, I'll have to rely on unauthenticated tokens, which anyone can get. And I've got to cross my fingers and hope that there's been some level of access applied to the unauthenticated token. So I'll first need to begin by getting the identity ID value, or the identity ID for this identity pool ID, which we can get from the application. Bit of a typo in here. Always forget my region. There we go. So we've got our identity ID now. And using this, we can then get a set of credentials using the following command. Now, don't get too excited. These credentials might have no access given to them at all. We'll have to enumerate the value of these tokens later, but they are legitimate AWS tokens. Their value remains to be seen. So we're using the get credentials for identity command. We'll paste in our identity ID from the previous command, and that will give us the familiar looking access code, secret access code, and session token that, if you're familiar with AWS, you've probably seen lots of times. But in order for me to use these values, I need to set them as environment variables inside my attacker machine so that I'm tricking AWS into thinking that I am this user in another subscription. To do that, I just run export, the name of the environment variable, and then the key. But I'm not going to bore you copy and pasting all of these different values into the command line. I've got a nifty bash one-liner that I can use to quickly transform those values into the correct format for environment variables. And I'll paste that in. I'll very quickly read through what it's going to do. So we begin with the same command as before, get credentials for identity, but then we're forwarding the output from that command into JQ, which will lift out a couple of fields, rename them into the value names that they should have to be environment variables. And then we're also using Perl to do a little bit of formatting. And there they are in the correct format. So in order for me to set these as environment variables now, I can just run that previous command again inside a for loop, which for each of those lines, it will run a command. And the command will just be export this value. So export this as an environment variable. It's quiet, but we can check that it's worked by running the same command that we ran at the beginning, which shows us who we're logged in as. And you can see now I'm no longer logged in as root in my own subscription, but I am now this Cognito identity credentials in the unauthenticated role. Let's see if we can gain access to that bucket. And we can list the contents of that bucket now. Let's copy it down to our own machine. I'm just saving that file locally under the same name. And we can cat that out to the terminal and have a look inside. And we've got a bit of a flag. We've gamified our hacking and securing the cloud course to contain flags so that people can compete with one another. One year for a course I ran in Japan, I gave away some some Doge coins just before they went big. But yeah, that was our indirect attack. And so what we did there, we broke into another service called Cognito through a web application by gaining those values. We transformed the identity pool ID into an identity ID, which we could then use to get a set of tokens which granted us access to the bucket. So the bucket in this case was secure. It was the other applications that lived around it. And that is the very nature of an indirect attack, breaking in through another application. What about direct attacks then? Well, we're looking primarily here at misconfiguration of buckets that have been unintentionally exposed to the internet or have been set up with broad permissions so that anyone can access them. From the attacker's perspective, the biggest challenge here is in finding them. With traditional on-prem infrastructure, bad guys can use network scanners to quickly find their targets inside of the network. They can just scan through a range of IP addresses, or they can do some DNS brute forcing. In storage, we have to guess the names of buckets, and there are some tools out there that are designed to do this for us. The only thing they need to know from us is some keywords to do with our target. So that might be the name of the company or the name of a product or service that that company hosts or provides. And that tool will then combine that keyword with lots of other common words that are found in bucket naming conventions. And all of that is through a dictionary attack. We've got a tool that we're going to give away for free at the end of this webinar, which will allow you to check your own buckets to see if they would show up in these dictionaries, which are known to be used for malicious purposes. Also, application reference. It might be that you've found some source code for an application in a GitHub repository, or you've downloaded an application that your target provides, and you can see that it's reaching out and trying to connect to a bucket to fetch resources. Once we know the name of that bucket, we can begin enumerating the permissions that have been set. The biggest challenge here is discovery. But we have some awesome tools at our disposal to help us do this. First one is buckets.greyhatwarfare. This is essentially like Google, but for open buckets. You can search for the contents of files in here. You can even search for regular expressions of patterns of data that you want to see. So you could search for credit card details, for example. If you know what a credit card number looks like, you can define that as a pattern, and this will go off and tell you all of the buckets, which will give you those details. You could look for classified strings to do with secret information, which I'm not going to disclose here, but if you knew them, you could search for those and you'll probably find something. The service itself is free to use. Go and check it out. It can be a real eye-opener for just some of the stuff that's available out there and how easy it is to use. But if you do want to pay, you can gain access to more indexed buckets. But it's definitely worth checking out for free, if only to raise awareness, maybe within your own dev teams. So we're going to have a look now at bucket discovery via application reference. Now, in this little video, I conducted a scan of every website hosted on EC2. So that is a lot of endpoints. Took me some time to scan those. And once I did, I went through the source code of the front page of every website, and I looked to see if there was any references to buckets. It was a massively inefficient way of doing it. This was actually part of a different webinar to do with EC2 and host discovery. But it shows us just how this bucket discovery can be industrialized and run at scale. The scanner I ran here was limited just to EC2 instances, but there's no reason you couldn't run this across the entire internet. The scanner I use could theoretically scan the whole internet in about 45 minutes. So it's pretty cool. Okay, so first things first, I needed to fetch all of the IP addresses for all of the EC2 instances that exist. Luckily for me, Amazon provide a JSON file that contains all of this information, and I've just downloaded it. And it's in this format. We can see an IP address there, the region of that host. Now, this JSON file contains lots of stuff, not just about EC2 instances. So I'm going to need to build a filter for that JSON data using a program called JQ. And here I'm just looking for records that are related to the EC2 service. And I'm going to further filter those just to return the IP addresses. So now we're looking at IP address ranges used exclusively for EC2. We're also going to list out the region here. And the reason I'm doing that is because there is a region I'd quite like to avoid in this scan, and that is the US Gov East and West regions. Don't want to touch them. It's just hassle that I do not need. So we're going to filter those out using JQ. So we're going to ask for the same things as before. Where the service is EC2, I want you to return the IP address if the region is not US, Gov, East or West. So we're just adding that caveat into the filter now. Awesome. So just to test that that filter works, I'm going to search through all of the results for the string US Gov, and I can see that no lines are returned. So my filter works. I'm not scanning government IP address ranges. So introducing ZMAP then. You've probably all heard of Nmap. It's the de facto port scanner, but ZMAP is like its high-speed brother, if you like. It's nowhere near as feature-packed. But if you give it an IP address range and a port, it will tell you which of those hosts are listening very quickly. And the output, when it finds a host which is listening, is simply to print the IP address to the terminal. It's not the nicest reporting format, but this is perfect for what I want to do next. And that is to feed the results into a program called zgrab. Now, zgrab is going to connect to that port and bring back the main page of that server. Zgrab can speak in lots of different protocols, but here we're using it with HTTP. And when ZMAP passes it an IP address, it will go and fetch the contents of the main page along with all of those response headers. So to chain the whole thing together then, I'm going to run zgrab. Or for each line that comes out here, I want to run ZMAP against that IP address range. And for any hosts which are listening on that port, I want zgrab to save the response from that web server. So, like I say, it's probably the most inefficient way of doing this, but the journey is quite interesting, I think. I've saved my results into this CSV file and I've applied a little bit of formatting to turn it into a CSV file. It's just going to make my scripting that much easier. And now I'm going to define a regular expression pattern which should find buckets inside of those main pages for websites. Now, there are 4 different formats that AWS uses for its S3 buckets, and I'm just looking for one of them here. And I found lots of mentions of buckets in those results, lots of duplicate results as well. So I've used a sort program there to unique the list. Now, for each of those buckets, I'm going to output the name of it to the terminal, and I'm also going to run an AWS command to check the contents of that bucket to see if I can read it. I'm going to enumerate the permissions on those buckets to see which ones will let me access their stuff. A hacky little bash one-liner here. I code quickly, but not necessarily efficiently. Not until maybe the second revision or something. Okay, so it's outputting the names of those buckets and it's listing the folders which are available. A lot of these are coming back with access denied, and that's good for them, good for security. But there were a few there that were returning the contents of their buckets. I'm going to do the same command, but I'm going to list files recursively. You can see I've gained access to lots of contents for web servers and lots of assets. Now, there's one bucket in that list that caught my attention, and I'm printing the name of it here because I've worked with this company to fix the problem, which they have now done. And so the Nova Music platform is kind of like Spotify for upcoming African artists in Africa. It's an African service, but this bucket is completely open. It's meant to be a streaming service, and you're meant to have to pay to gain access to some of these tracks. However, because the bucket is open and it was referenced in the application, we could go through here and download all of their intellectual property. The reputational damage that would have resulted from something like this would have prevented any artists using that service ever again. I mean, for customers, it's great. They get loads of free music, but that name now will become synonymous with a massive breach if this were ever to get out, which, as I say, I worked with this company to help fix this issue once I discovered that it was vulnerable. Cool. So in that example, we had a direct attack. The bucket was open and exposed. The only challenge from our part was to find it, gain access to the contents. Let's have a look at some contemporary threats, beginning with MageCart. Now, we introduced this at the beginning as being a supply chain attack. It actually delivers a nasty piece of JavaScript which was designed to perform credit card skimming locally in someone's browser. But this all comes down to a misconfigured S3 storage instance. And this storage was being used to host script assets for other websites. So essentially, a supply chain attack. Someone's able to break into that bucket, replace the legitimate bit of script with something that acts in a different way. And now all of these websites that rely on it will call the attacker's script, and that will cause it to be executed on lots of people's browsers who all trust the site that they're visiting. You know, the SSL and TLS certificates are all there. Your customers will have the little green padlock in their browser that they have learned to trust, and yet still they would have this script delivered to them and their credit card details compromised. And so this affected 17,000-ish domains, and about a lot of them were in the Alexa top 2,000. If you're not familiar, these are highly reputable sites. And so here's a bit of a screenshot here. There's an excellent write-up which has been done. I forget the name of the site now. I'll remember that at the end. I'll pop that into the chat. So there's a really in-detailed write-up about just how this script works, what are the indicators of compromise, the domains that are related to it, and how it goes about compromising the browser. But essentially, supply chain attack, writable bucket, publicly exposed, which allowed the dropping of this malicious script, which was then called upon by sites that trusted that bucket. Massive impact from just one hack. Now, I particularly like this. I mean, it's terrifying, of course, but it's quite ingenious at the same time. We're all familiar with ransomware. Crimea, Petya, Tesla Crypt. You've probably not had, or hopefully not had hands-on with any of these, but I played around with them in some malware analysis. I played around with tools like Cuckoo to do some automated malware analysis. Very clever tools. They're optimized for speed and destruction, and so they can render a machine useless in little under a minute. But one of the ways that they're able to do that is by only encrypting parts of the file, because you don't have to encrypt the whole file to render it useless. Now that has its own problems. It might be that some data is recoverable. However, in this cloud native proof of concept ransomware, the whole file is encrypted. And in this one test, about 100 gig was fully encrypted, irrevocably encrypted in 1 minute 47. So that's quite good going. Now you might be thinking to yourself, well, this is cloud. If something is going to access 2,000 objects sequentially, delete them and replace them with a different version, that's going to generate an unholy amount of logs. My monitoring software is going to pick up on this. I'm going to know if somebody does something as noisy as that. You will. The problem is after about 5 minutes, because that is a latency between things happening and CloudWatch events. Of course, by which point it will be far too late. So devastating attack, terrifying. How on earth can this happen? How can we stop it? Well, in order to understand how it happens, we're going to draw a comparison between our cloud native ransomware and our on-prem instance that has been compromised and its hard disk has been encrypted. Now, as I said before, we want to decouple our solutions. So we're going to be talking about individual services within cloud that work together to perform this malicious function. First of all, we've got our VPC NAT in cloud, which would be analogous with our exposed service socket. attacker breaks in through that service, through the exposed port, and is then able to interact with the host CPU or an EC2 instance. From there, traditional ransomware would use a service account to gain access to high privileges in the machine that it needs to encrypt the contents of a disk. In cloud, we'd be abusing IAM roles, specifically IAM roles that have access to or can be granted access to the key management service. Now, the thing to bear in mind here is that the attacker will be granting your IAM roles access to their KMS. They're allowing you, well, they're allowing your IAM roles to read a public key that they've created in their own key management service. That then is used to encrypt the contents of an S3 bucket, or traditionally on-prem, that would be a hard disk. So it's a really clever use of the key management service, and this is the linchpin of this attack. But how do we prevent it? Well, object versioning is the best way. If a file is deleted and replaced with something else, that's just going to keep the old version. So you can roll back to the unencrypted version, no problem. However, if MFA delete is disabled, then the attacker can simply delete the old version before creating a new one. So really, to stop this attack, you need two technologies set up properly. That is object versioning and also multi-factor authentication delete, which is not as straightforward as a lot of things to set up in cloud. You have to have your own authenticator, like Google Authenticator or an app on your phone, and you need to be sharing the tokens with the service. So it's not as straightforward as clicking a switch like object versioning is, but it's well worth doing when you consider how criminals are getting their money nowadays. It all seems to be through ransomware. It's if you forgive the bit of admiration, but it is an excellent business model. It's a very clever business model for them because it reduces the risk on their behalf. And as we migrate to cloud, they will follow us. So look into those technologies if you haven't already. But how would an attacker find my writable bucket? Well, we had a look at some examples before using entire internet scans to look for bucket references. But I've written a nice little tool which leverages the indexing that Google performs anyway. And so you can use things like Google dorking to perform very specific searches to find buckets. But this tool does quite a bit more than that. It uses lots of different regular expression patterns to define all different forms of buckets, and it uses a custom search engine, which is all accessed via the command line through a little Python script that I've thrown together. The other nice thing that this tool does is that it will extract document metadata. So if I find an Office document, I'll be able to see exactly what version of Office my target is using and the name of the person who authored the document. And we can also enumerate the access control permissions that have been applied to that bucket, as well as quickly checking how much stuff is in the bucket. So how many gigs and how many unique items are in there. So quick demo of this. Demo fairies be with me because this is a actually live demo. So a little script I wrote is bucket search, and if we check the help, it's pretty straightforward. We tell it what kind of files we want to find, so PDFs, Excel spreadsheets, whatever else, and then what are our search terms, what kind of thing are we looking for. So I'm going to begin by searching for some credit card details. Now, before anyone gets too nervous, I have changed my script so that it doesn't check all of the sources that it could do, because if it did, we would be looking at some very real credit card details. Instead, I found some sample data, which is provided by a service provider to help people set up data lakes, just to give you an idea, really, of the kind of things that you could find. So I'm going to search for SQL files. My query will be MasterCard, and we'll see what we get back. And so we've got a link here. We've got a bit of a sample of contents from the file. This is definitely an SQL database backup. And we've got a link to the file here. So if I copy this, I can download that. And we can take a look inside. So yeah, it's absolutely SQL database, and we can see our records in here. Our card number, expiry date, card type, American Express, Solo, JCB. I'd like to say this is an isolated incident, but there are so many buckets out there like this that really shouldn't be exposed. And this tool was pretty straightforward to put together. Granted, this is my job, this is all I do, but yeah, the bucket itself is out there, and it would likely be discoverable in something like buckets.greyhatwarfare. So you wouldn't even need the technical expertise. You could just pay a subscription fee and search for MasterCard, and that would work. Give an example of some of the other things that it can find though. I'm searching here for the word government, and we're looking for Office Word documents. And the reason I'm searching for this is two reasons. One, to demonstrate the metadata extraction, lifting out employees' names and the version of Word that they're using, as well as the bucket enumeration. There are some buckets in here that allow us to enumerate exactly how many files are in them. So yeah, we can see the names of authors coming through. This the government says bucket is completely open, and we can read the access control policy as well as the contents. It's authored by Gunter using version 16 of Microsoft Word back in 2020. And we're about to see just what else is in that bucket. We've got another 15 gigs worth of information amounting to 21,000 files. If we wanted to, we could connect to this bucket and browse around it straight from the command line, just using our AWS S3 command. I'm going to stop that there. Now, before anyone asks, I've been told I'm not allowed to distribute this tool because with certain keywords, it is very easy to find government classified information. When I rehearsed this, I showed my boss, and I was like, you know, I want to show this. It's government classified information. It shouldn't be viewable. And you know, I thought it would be great for the shock factor, but it is perhaps too much shock for a quick webinar. Anyway, we are planning on releasing this at some point if we can perhaps find a way of toning it down a bit. So yeah, it makes it quick and easy to find tons of open buckets. But what about defense? What can we do to start protecting ourselves against some of these threats? Well, the first thing I'd recommend is having some kind of anti-malware running in the cloud. And we've got cloud native anti-malware. It doesn't have to cost you the earth. There's an excellent open source project over at this short URL. This will take you over to GitHub, bit.ly/s3antimal. And this is a fantastic way of scanning your buckets using Lambda functions, which can be incredibly efficient or cost effective. Lambda functions, you'll build per execution, and I believe you get about 1 million executions a month. You may need to check me on that, but I believe you get about 1 million executions of a function a month. So you can potentially run this for free. No need for expensive software vendors for cloud native anti-malware. And the process is pretty straightforward, actually. Inside of cloud, whenever the S3 object created event occurs, so you've just uploaded something, the ID of the file is forwarded over to this function, which essentially runs clamav, which is a Linux-based anti-malware piece of software. It fetches its latest virus definitions from a separate bucket and then scans the file. Depending on the result, it can handle the file in a few different ways. It could quarantine the file, it could delete it entirely, or it could just tag the file with a piece of metadata that says infected. So you can keep your malware samples and maybe forward them on to an anti-malware vendor so they could create new signatures for this thing, whatever it is. So it's actually fairly straightforward to get up and running with. And the GitHub project has full documentation on how to set that up. In terms of configuring your storage correctly, we've highlighted a few technologies in this course that will help, in this webinar that would help, but we've got the full documentation here from each of the vendors on best practice for setting up your storage. Definitely review those, make sure that your storage is safe because it is so fundamental to so many applications. We've got a tool here, which is more of an offensive tool, but you can run this against your own business to get an understanding of the exposure that your cloud subscription has. And then finally, we've got this bucket checker script, which is a nice little script that will quickly and easily tell you whether or not you are exposed either to reconnaissance techniques or to some of the ransomware techniques that we looked at. I'll just run that very quickly. Okay, so you don't need to give this tool any arguments, but you do need to have signed in to your AWS subscription on the command line. If you give this script to one of your devs, they'll know what to do with it. And so you just run it. It's going to go off, check your buckets to see which ones contain words, which commonly occur in dictionary attacks. And then it's going to tell you which of your buckets do not have versioning and MFA enabled. So you can go through those and see what you can do about adding versioning. And then, of course, it wouldn't be a webinar without a cheeky plug for our courses. So you've got a QR code there if you do want to learn more about cloud security. And like I say, this is just one service among many. In our full Hacking and Securing the Cloud course, we look at forensically examining snapshots for EC2 instances, identifying vulnerabilities in container technologies like Docker and Kubernetes. We look at AWS Cognito abuse and tons of other stuff. Like Alan said, it takes about a couple of days to get through, and it's very hands-on. Lots of exercises to go through. It's not just chalk and talk. We'll be taking you through and we'll be arming you with the tools that you need to not only attack, but also defend cloud subscriptions. And so that's all from me. I'm going to hand back to Alan now, but I will be available at the end of the webinar if you've got any questions about anything that we've talked about today. So thank you very much. Alan, over to you.
Thank you very much. I hope you found that interesting. Just to recap though, there's on our website, there's a whole load of training courses which are maybe of interest, both from the beginner right the way through to advanced level. And as you can see on the screen, there's a couple of items that are coming up for this actual training course on the 29th of September and also the 25th of October. Generally speaking, what we normally do is we only attend at large conferences and via partners and on in-house type training. So this is something we've only started doing since the lockdown happened. That we're starting to offer these remotely. So please take advantage of these because they're great for individual people. And just by entering that discount code, you can get 20% off the discount on all the training that we're running. Don't worry about having to copy down that code because we will be sending out details of all this training at the end, and it will include the discount codes. So that's probably it from me, really. There will also be a questionnaire at the end, which is worth completing because if you tick a box that says it's okay to have a chat with you, we will enter you into a free prize draw, and that prize draw now we're taking to do a free training course. So the value of those training courses for free is not too bad, really. But that's a bit about it from me, really. Hope you enjoyed the training. I'm going to now go back to Q&A, just so any questions that have been posted, we've got a chance to answer them for you. Lizzie, can you read them out for us?
Great, yes, thank you, Alan, and thank you, Scott, as well. That was a really good presentation there. I actually really enjoyed it myself. So yeah, as you can just see on the screen here quickly, we do have a prize draw offer ahead. So yeah, if you do want to speak to one of our team about if you're interested in any of our courses, please go ahead. But we might as well get straight into this Q&A session now. Please submit your questions if you have any regarding the cloud course or the webinar that we've just watched. So first question that we've had in, Scott, is how important is the principle of least privilege when it comes to securing services?
So, as we saw in our indirect attacks, we were able to break in through Cognito because the read access for the unauthenticated user had been applied to that IAM role. So when we talk about the principle of least privilege, it's exactly the same idea, but we're thinking now about applying it to IAM users and roles and dialing that back as much as possible. Acting as always on the assumption that the attack can come from anywhere. It might be that your web application is compromised or a hosted database. And if either of those applications are given access to another service, you can bet that the attacker will find that and abuse it. On top of that, there are also some individual permissions, like the assume role policy permission in AWS, that can be used to very quickly escalate from having low permissions to having very high permissions. And I believe CyberArk have written a great tool to check that out in your own subscription, I think called SkyArk. I'll verify the link for that. But yeah, it's probably the biggest problem that we see in our engagements is poor IAM permissions.
Great, thank you for that. Another question that we've had in, Scott, is, are there any automated tools I can use to get a better understanding of my cloud security risk?
Yeah, absolutely. So what I'd recommend, we've got our own cloud enumeration tool, which we link to in one of the previous slides, but also the bit of a shout out to the NCC group. They've written a nice tool. Just quickly bring that up. And that's called Scout Suite. It's pretty easy to get up and running with this. I'll paste a link to it in the chat. If I can find the chat, there we go. Yeah, so I've just popped a link to that in the chat, and this is really quick and easy to get going with. Your devs will be able to run this quite easily with any permissions that they have. Ideally, you want to have a role set up that has global read or list permissions across the subscription, and it generates quite a nice little web report which will highlight individual areas within your subscription which require attention, and it will tell you exactly what you need to do to fix them. Now, of course, this is only an automated tool. There's really no replacement for having someone that really understands cloud security, getting in there and digging through the weeds. But as a user, this is a fantastic tool to really get that low-hanging fruit and get your environment in a much better place.
Great, thank you, Scott. Another question that we've had in just now is, cloud brings in the additional consideration of legal permission from the service provider for active testing, being squeaky clean even while testing our own stuff. At what point would you consider it vital to get permission to run tests on your AWS, Azure, etc. services?
So that's an excellent question. And just before I dive into it, for the benefit of everyone else who might not be familiar or maybe that familiar with the division of responsibility, within cloud, yes, you own maybe the EC2 instance, but they own that underlying infrastructure. And more often than not, that is a multi-tenanted environment. So certain tools and tests may affect other users, especially ones that generate massive amounts of traffic. Now, just referencing all three organizations, so GCP, AWS, and Azure, their pen testing policy is actually pretty forgiving. If it falls in your under your responsibility, you are allowed to test it. But the common thread across all three vendors is that they do not want any kind of API flooding or denial of service or distributed denial of service to test your applications. But other than that, they are all pretty forgiving. I think it's only really Azure that still allows you to notify them. They quite openly say that you don't have to notify us of a test, but if you'd like to, here's the form. Please abide by the pen testing rules of engagement. On top of that, another little note, GCP is slightly different again, in that if you're conducting a pen test for a customer in their GCP environment and you find an issue that you think may affect other customers as well, so this is not just a individual issue, this might be systemic within GCP, you can highlight it to Google Cloud, and they've got a bug bounty scheme and they'll give you some cash for it. So I mean, from my own experience in terms of massive amounts of traffic flooding in cloud environments, like I say, I scanned the whole of EC2, but I actually did that from an EC2 instance. I figured, it's going to be closest to a lot of those hosts. It's going to have pretty decent access. So I actually used one of their own machines to do this, and they were quite happy with that. Another consideration, actually, when it comes to cloud pen testing is in terms of accrued costs. A lot of services are billed by consumption. So as a tester, you have to be mindful that you're not going to abuse a service and cost your customer quite a lot of money. A good example of this might be the AWS Secrets Manager, or cloud storage is billed by usage as well. So I think I've probably covered tons of different things there, but I hope I managed to tackle the question. But I mean, from my own experience at least, they all seem fairly forgiving is the short answer. But it is really denial of service that they have a bee in their bonnet about.
Great, thanks for that, Scott. There, that was a really detailed answer. We do have another question actually as well from one of our attendees. If you could just answer to the best of your ability. So, in your opinion, in terms of security infrastructure, which is the biggest three major cloud platforms like AWS, GCP, Azure, are considered the more secure in their respective environments?
Sorry, let me reread that question. So
sorry, I can reread it.
Yeah, no, it's okay. I've got it up.
Great.
So I guess, are you asking really which is the most secure? It's very difficult to say, and it will come down to your individual use case. For example, I think that user management within Azure is actually really straightforward. It makes it quite easy to monitor accounts and provide really strict controls about what hours they're allowed to log in and connect and do work within the environment, as well as from which geographic locations and even devices they're able to log in through. So if you're prepared to pay for the kind of premium level subscription and you're primarily concerned with identity and access management, I would say Azure is probably the easiest to get it right. However, when one thing I'll tackle, because it's quite it's easy to compare across all three, is a piece of functionality called the metadata API. Now, for those that haven't had any hands on this is like your orchestration plane that sits behind the things that you build. An easy way of thinking about it is it's the puppeteer and the strings that control your things. So, you might have a web server, but it was created and controlled by this orchestration plane, and we call that the metadata API. They all work in pretty much the same way. You send a web request to a specific endpoint and you get an answer. But the ways in which all three vendors have approached securing this differ. I would say that Azure have actually done a really good job in securing their metadata API. I think they've learned from the mistakes of vendors who have kind of got there first. AWS, for example, have a version of their metadata API which does not require the use of tokens when you send requests. Sounds like a small thing, but really this opens up quite a lot of web application vulnerabilities, like server-side request forgery, a way in which we can trick a web application into sending a request somewhere else for us. And as an attacker targeting cloud, we would want that request to go to the metadata API. Through SSRF, we wouldn't be able to do that if tokens were required. So straight away, AWS kind of lose points for me there, in that they still support that legacy way of interacting with the metadata API. Now, in fairness to them, they've created a new version that does. However, it's up to you to know about it and make sure that your services are using it as opposed to the others. So yeah, really difficult to say. I think you'd have to take it on a service by service basis, but they're probably most broadly applicable ways of looking at it: user identity and access management, and also the metadata API. So yeah, hope that helped.
Great. That is actually all the questions we've got for today. So just want to say thank you to everyone who's joined. Thank you to everyone who's asked some questions. We really hope you've enjoyed and found the webinar interesting today. Like Alan said before, we do have a survey at the end that we'd be really grateful if you could answer. It also includes some questions about obviously the prize draw if you'd like to get involved too there. And yeah, just like to say thank you again. Thank you so much, Scott, for the presentation. It was really, really good.
My pleasure as always.
Great. And yeah, I hope everyone has a lovely day wherever you're from in the world, and hopefully we can see you on our next webinar. So thank you, everyone. Goodbye.
Bye everyone.